Welcome to Playing with Junk. This time I want to talk about capacitors, especially broken capacitors inside this Acer beamer here, and also supercapacitors like this here. They come from HP servers, and they are in the servers for maintaining the cache data from the RAID controller. And just in case if you think I'm talking a bit slow, it's incredibly hot right now. It's 35 degrees centigrade outside, and it's about 30 degrees here in my lab. You probably can see that here. That's the temperature down there. Okay, so I'm sorry if I have some problems with thinking and fast talking and whatever. Okay, the problem of this beamer here is as follows. When I'm plugging it in here, I hope you can hear that. It tries to start, but it can't, so it goes on and off and on and off all the time. You can also hear the fans, they start spinning and stop. And funny thing is, if you leave that for about half an hour or maybe 20 minutes or so, it suddenly starts and then it works as ever before, no problem about it. So I think we have some bad capacitors inside. Biggest problem with these compact devices is always how to take it apart. So fortunately I have already practiced that before, so I know what to do. Swiss-made Cyber tool comes with a super handy tool. So it has these bits here, that's 4mm bits, and that's the church clock. It's 1845. Okay, that's 4mm bits. And if you look inside this bit holder, it has two steps. One is 4mm from the bit, and you also see there is a gap. So it goes exactly to these screw posts of the VGA connector here, which is, I don't know, 6mm, no, 5 point something. That goes in the outer hole, and this one goes in the inner hole. That's a clever piece of tool. And it has more clever things like that. But I don't want to explain that tool. I want to fix this beamer here. So we had two screws and these two cable or connector fixing posts. Then we have, okay, how was it? Oh yeah, okay. First have to remove the lamp. It's under this cover here. We discover the lamp under this cover. That's the lamp. Just a A short arc lamp, the usual stuff. It's not an LED beamer, it's not that modern. It's not a HD beamer, it's just a TV resolution VGA input beamer. Okay, to pry that apart. So you have to be careful, there are a couple of cables here. So that's a flat one that goes to the buttons, and this one has a connector like that. That's the infrared receiver on the top. There is a second infrared receiver on the front, so wherever you aim your infrared remote control, you will hit it and it will receive. Okay, as I said before, there is a front infrared receiver, and we have to disconnect that because it is attached to the front and we cannot remove the front. Well, we can, but then it's difficult to reattach this, so this will simply be, oops, there are some plastic parts. I hope I don't need that anymore. Okay, that's it. There's a screw, there's a connector. Side panels, they just fall off like that. Well, at least this one. We don't need to remove the other one because I think we can. Okay, where's the hidden screw? Nowhere. It was just clipped to the rest of the device. Okay, that's not plastic. That's a magnesium base. I like that. It's light and stable. Okay, then we have a couple of screws. More screws on the side. One, two. Okay, now we can remove this aluminium frame here. Then there is one connector here that we should disconnect, and there is a large connector underneath that label here. It's a board-to-board connector, and there is another flat, no, not a flat, a connector like that, and then we can flip over the board. So now that's the connector that goes to this board here, where the DLP panel is attached. You can see the heatsink here, because the panel, the DLP chip needs to be cooled because all the light beams on that chip will be reflected. DLP is like a mirror with individual mirror pixels that can be moved, so they will reflect light or not, or maybe more or less. it's a clever design. The problem is you also need a color wheel, because this mirror will only reflect white light. So you need a color wheel for red, green and blue that spins very fast, so it makes a red picture, a blue picture, a green picture, and repeats that, and a white picture too. And that's the reason when you have a DLP projector and you move your eyes quickly on the screen or over the screen, then you see a rainbow effect. So that's because if you move your eye quickly, you can see the individual colors of this picture. So then we need to remove the high voltage power supply, the lamp power supply with the igniter circuit. Okay, that's this board here. Then there is a stupid connector with a clamp that is hard to get off. Then we have another connector here, and I already see the problem. Can you see the problem too? I will show you. Can you see the problem now? Here it is. A bad capacitor. A pregnant capacitor. It has been bad, now he's pregnant. Or she? I don't know. What is a capacitor? She or he? Well, maybe an it. Okay. So I will take out this power supply, replace the capacitors here, maybe 1 or 2 capacitors down here, and then we will see if that thing works again. So I changed the capacitors. You can see new, old. The small ones usually are not a problem. I also changed 2 capacitors here because they are in between, underneath the heatsink on the hot transformers. These transformers here usually get relatively warm, so they're in a bad spot here, temperature, from the temperature side. What I'm wondering is, we have 3 good. From the sign here it looks like Nippon Chemicon capacitors, and the big ones are Altec and OST. No name capacitors in my eyes. I have never heard. Looks like Chinesium material. I know why they take this one, because they are cheap, and if they fail you have to buy a new beamer, and that's good for the business. But why do they take good quality small caps? I don't know. Maybe they got them for free, or I don't understand these manufacturers. Okay, let's see if the beamer is working again. Did you see it? I forgot to install this insulation pad here, so I had to remove the entire power supply again, but I didn't show you because that's boring. Okay, again, that board goes here. Well, let's see if it works better now. Where is my power cable? Here it is. I hope it works without the top cover. Nope, doesn't work, and the power button is not attached, so it's a bit difficult. Okay, let's try it again. Nope. I think I probably forgot a connector. And I have already screwed everything together, so let's do it again. I think there's the problem. The connector is not completely in. Okay, now it looks better. Try again. Okay, it's still not working, but did I mention that it is hot today? I did not install the lamp, and when the lamp is not installed, you cannot power this thing on because there is a safety switch right here. That's it. And that safety switch will be pushed by what? By nothing. Okay. By the top cover, or by the bottom cover, to be a little bit more precise. Where is it? Here is it. Yeah, that's the Tapsy tab that pushes the safety switch that makes the beamer run. But, well, the connector was anyway not connected correctly, so maybe we are lucky now. So be careful where I put my fingers. Whoops. Yeah, power switch is blinking. It didn't do that before. Goes blue and the beamer turns on. So it seems it really was that capacitor. Okay, let's see if we get a light. Yep, we get some light. We also get some focus. Yes, Acer. You can create a personalized startup. Okay, we have to turn that picture upside down because the beamer was mounted on the ceiling. Menu, doesn't work. Source doesn't work. Okay, menu, hello. You can make a personalized startup screen. Okay. Oh, we have a zoom. Yes, Zoom. Zoom, zoom, zoom. Okay. Why is the menu button not working? Power. No, I don't want that. Menu. Maybe I have to push a couple of seconds. No. Maybe that menu button is broken. No. Okay. I have to find out later how that works. So I first put it together. Maybe I need the remote control. No, there is a menu button. It must work. Maybe it only works when a signal is attached. Okay. It's not a problem to solve right now. Well, beamer is repaired. Let's talk about the capacitors. That's 3 capacitors. They're all the same. This one has heat shrink tube around. These 2 here have it removed. And if you look at those, you probably see that this one is pregnant. It has bulged up. This one is flat, and now guess which one is the defective. 3, 2, 1. You're wrong, they are both defective. And the problem is this one got a low resistance. This one got voltage too high. So it bulged up, but the cause of the trouble is that one. And in fact, the main cause of the trouble is the missing parts here. Okay, as I said before, these supercaps here come from HP servers. They have been used from the G7 on, I think, maybe G6, but certainly G7. And generation 8, yes, they use them too. The problem is it's 2.7 volts per capacitors. They have 2 capacitors in series, as you can see here. They use 3 wires. 1 goes to the positive side and 2 are connected together to the negative side. And that's one part of the problem. There is a space for 2 probably resistors, maybe Zener diodes, I don't know, but they are not in place. They are also not in place on this one, and certainly not on this one. We can see that because it has a cover, but it's also the same on the third one. Now, why do they need supercaps in a server? These supercaps are connected. Normally they use batteries. Let me start with that. That's nickel metal hydride. Yes, here it is. Water batteries, and you also see they do bulge too. That's not so bad. Maybe sometimes they look much worse than that. Okay, RAID controllers have a cache RAM. That's the RAM module from HP RAID controllers. It has 256 megabytes. It is used for read and for write operations. So that means this is called by HP, they call it a RAID accelerator, because all the operations that have to be written to the disk, or if they read from the disk, they first write it to the cache or try to read it from the cache. Maybe it works, maybe they have to go to the disk anyway. The problem is if you write to the cache and before it is written to the disk, and there is a power outage, you will lose data into your cache module. Maybe it's 128 megabyte. It depends how you distribute that between read and write cache, but you probably lose half of the storage here. Even worse if you have a modern one with a gigabyte of cache. So probably you have 512 bytes of write cache. And if that data is not yet written to the disk and your power fails, this is gone. So you need a battery. The older versions have just RAM, a RAM controller here, a little bit something, and a battery. So what happens is that if you lose power, the RAM will keep its data because it's battery powered, and it will keep its data as long as the battery has power. Now, if your battery is good, this will probably hold for 48 hours, 72 hours, depends on the model, on the size of the battery, something like that. After that time, if you can't restore power, which is not often the case, but you will lose your data. Now, they came up with a clever idea. They have these RAM chips again, RAM controller, a little microprocessor here, more RAM chips, and a flash memory chip, that one. So what they do is, in case of a power failure, they use this supercap, which has a much lower capacity than the batteries, but it has enough capacity to give time to write all the data from the RAM into that flash chip here. And when it is stored in the flash, you can power down the entire board. It is saved, like it's the same flash chip as in the USB drive or in an SSD drive. So it doesn't need power to keep your data. And that's why a smaller battery, or in this case a smaller supercap module, it has only to provide power for, I don't know, a minute or two until all the data, this 1 gigabyte, is written to the chip. 1 gigabyte to flash chip, I don't know, takes a minute, takes half a minute, a couple of seconds, I don't know how fast they are. And when power is restored, they will read that chip back to the RAM, and then when the disks are ready, they will write the data to the disk. So that's why they need batteries or supercaps. Now, what they did is quite simple. We have 5 volts and we have ground, and we have 2 capacitors. Okay, I made the wrong symbol, so that's a capacitor, that's a capacitor, it's an electrolytic. They simply put them in series. Okay, it's that ugly, I know. Okay, so that's what it is. What they did. So normally, if everything is okay, you have 2.5 volts on one cap and 2.5 volts on the other cap. But if one capacitor fails and starts to create a shortcut here, this will go up to a maximum of 5 volts. And as we have seen here, maximum voltage is 2.7. If it gets higher, it starts to boil. The electrolyte here starts to cook. It gases and it builds up pressure, and that's the reason why this looks like that. So the problem is this capacitor got faulty. That's the flat one. The other one got a too high voltage and blew up. So at the end, both capacitors are faulty. So that's a sad story, because I always thought, oh, that capacitor is okay, I can use that. And oh, here in this case, both are bulged. Okay. That's another capacitor module from Dell. You know, Dell has its own problems when it comes to supercap modules, but they use separate wires for the two capacitors. They also have a temperature sensor. Okay, they have a temperature sensor too here, but they in fact charge each capacitor separately, or they have some sort of balancing circuit on the main board. Here, HP, they just tied the white and the black wire together. I think they planned to use separate wires for each capacitor. They also planned to install some resistors here, because, back to the schematic diagram, if you add some resistors in the correct size, this will help to balance the voltage. So if one capacitor gets a little bit bad, it's not a big problem, because there are still these resistors here that keep everything in balance. Maybe you could also use some Zener diodes, 2.5 volt Zener diodes, instead of the capacitors. But in their infinite wisdom, oops, blue paint, they decided not to install the components here. They decided to have these two wires here connected together, because it's simply cheaper, but they blow up after a time. So, you have learned something. Good night.